Hello everyone, my name is Anand Parmar. Now our topic is how changing data from terabyte to petabyte and how it affects security. First, first we need to know what is data. Data is a raw collection of information. Now, data growth is exponential, moving from terabyte to petabyte. With this growth, security management become more complex. In this, how does this massive increase in data volume impact security? Data explosion from terabyte to petabyte. In this, we understand how petabyte scale. 1 petabyte is equals to 1000 terabyte, or in another 1024 TB in binary terms. And it is equivalent to 20 million filing cabinets or 500 billion pages or text. This is a very large amount of data. Now, why does this matter? The scale of data growth. Security challenges with data. It is more in entry points, large data, more servers, databases, and endpoints. It is complex access control, harder to manage who can access data, what kind of data movement, replication, and backup increases exposure risk. It also monitoring difficulty, hard to detect anomalies in metadata, scale data, compliance burned, hard to ensure laws like GDPR and HIP are followed. Data source, IoT sensors, high resolution video content, artificial intelligence, model training data, cloud archives, satellite images, and many other things. Security stakes skyrocket with scale. In this, it affect financial impact, expanded attack surface, and increase complexity. It impact on data confidentially. Encryption become challenging at petabyte scale. Key management and storage require high performance. Insider threats become harder to detect. It is very high chance to encrypt our data. Distributed storage may lead to data leakage or unsecured copies. It also affect data corruption risk on a very large system. Maintaining chunks, hashes, and trails over petabyte of data is expensive. The challenges of protecting petabyte scale data. Outdated solution, critical bottlenecks like extended backup windows, ensuring data integrity across vast data sets, and many other things. For example, large enterprises face years long timelines to migrate or backup hundreds of petabytes, posing significant business risk. It also impact on data availability. Large data set equals to large storage cluster. Single point failure can affect more users. Second point is backup and recover become slower. Those attack on ransomware on petabyte scale data can cause long downtime, cloud redundancy, and distributed system are critical. Now, real world impact, productivity, and litigation risk. Productivity drains, like employees can waste 36% of their day searching of essential data lost within massive disorganized storage. Means a, a 36% of our day is waste in searching of essential data lost with massive data. It is very difficult to find in a large number of data or disarranged storage. Litigation costs, legal expenses rise dramatically as data volumes balloon, complicating e-discovery and compliance efforts. Case in point, Fortune 100 company reports skyrocketing discovery expenses due to sheer scale of their data holdings. Now, modern security strategy for petabyte. Addressing petabyte means to arrange the data in a very linear form. First is object storage, second is AI driven governance, third is cloud native backup. First one is object storage. Utilize object storage with fine grained access control and REST API for secure, scalable data sharing and distribution. It is a mm, very linear form to arrange data. Second is AI driven governance. They use a very large number of data daily. The future plan preparing for exabyte and beyond. Continuous data expansion. Data growth will relentlessly continuous beyond petabyte to exabyte and zettabyte, demanding future proof solution. Second is evolving security frameworks. Security framework must evolve to incorrupt zero trust principle, continuous monitoring, and automated incident response system. Third is strategic investment. Investment is scalable, resilient infrastructure is not merely beneficial but critical to safeguarding tomorrow involves data assets. or or in future we talk quantum safe encryption, autonomous security agents using AI, blockchain based data tracking, federated and decentralized data management. Best practices uses distributed storage with encryption at rest and in transit, apply zero trust models, implemented strong identity and access management called IAM, automate monitoring and incident response, regular audits and penetration test. Now conclusion, embrace scale secure with strategy. Moving from terabyte to petabyte is not just a storage problem, it is a security evolution. Requires smart tools, stronger encryption, and more automation. Future security success depends on scalability, visibility, and adaptability. In this, the leap from terabyte to petabyte fundamentally transforms data security challenges. Organizations must adopt advanced technologies and robust governance to protect their extensive data assets effectively. The cost of inaction is security at petabyte scale is not optional. Security must grow faster than your data.